Yes, class. Am I audible to all of you? Sara, Siddiqa,
Yes, ma'am.
Alia. Yes, Alia, you there? Alia Imam. Say yes or no if your mic isn't working. Text me in the chat column. Yes, class. In the last class, we had started with collision. Let us complete with collision. So collision is basically the act when two bodies collide and the velocity gets exchanged. So in 2D and all these, we had seen difference between elastic and elastic we had seen. Now, coefficient of restitution. What is meant by coefficient of restitution? Okay, Alia has left. Okay, ma'am. It may be due to her, it might be due to her internet issues then. See, elastic collision, inelastic, we have studied. Now, what is perfectly inelastic? These values of key will be clear first. Understand here. See, U1 is the velocity of body with mass M1. U2 is the velocity of body with mass M2 before collision. Now, during collision is the case when both the bodies are colliding. Then afterwards, V1 is moving and V2 is moving. Now, relative velocity, we all have studied in chapter 1. Velocity with respect to another object, right? So U1 minus U2, that is the relative velocity. This is what we have studied. So relative velocity of approach is basically U1 minus U2. Approach means with which the velocity with which the bodies are moving closer. Fine? The velocity with which the bodies are moving closer. So relative velocity of approach. This becomes U1 minus U2. Fine. Now collision occurs, the velocities have separated. Now the relative velocity of separation. See class, here we use U1 minus U2. We didn't use U2 minus U1. We use U1 minus U2. Why? See, if both the bodies are moving, unless and until the body which was behind, its velocity increases to a greater value, then only it will be able to collide. If the body will remain at their same speed, the distance between them will always remain same. For the bodies to collide, for collision to occur, the first body should move a little faster in order to catch the second body. Then only collision will take place. Fine. That's why U1 minus U2, because U1 is greater than U2. Then relative velocity of separation. Relative velocity of separation means both the bodies have moved. Now, after they are separated, if the body is moving, it means second body has the tendency to move away. Then only it is moving away from it. So relative velocity of separation means now V2 is greater than V1. Earlier, V1 was greater than V2, U1 was greater than U2, because this had to collide. Now, after collision, if this is moving, it means its velocity is greater. So this time V2 minus V1 is greater. Fine. Now it is the ratio of relative velocity of separation and approach. It is the ratio of relative velocity of separation and approach. So E, which is known as coefficient of restitution, it is what? Ratio of relative velocity of separation, that is V2 minus V1 to relative velocity of approach, U1 minus U2. This is the coefficient of restitution. Now, depending upon the values of coefficient of restitution, we have different cases of collision. If value of E is coming less than 1, it means this is elastic collision. If it is less than 1, 0.9, 0.5, that is inelastic collision. And perfectly elastic collision means after collision, the bodies are not moving now. If V2 is greater than 1, then it moves further away from the body. Yes, if V2 is greater. Who is this 1 to this number? 1527. Okay, Yasir. So yes, if the bodies are moving, they are colliding, then they are getting separated. So initial velocities, then they are colliding, they are separated. So initial velocity was higher for this body, they collided. Velocity, final velocity is greater for this body, that's why they separated. Now, if they are not able to separate, means the bodies have sticked to each other well. This type of inelastic collision we refer to as perfectly inelastic collision. So in this case, the final bodies for both the bodies remain the same. That's why their difference is 0. So E also becomes 0. Make a separate heading, coefficient of restitution. Then we'll do elastic collision in 1 dimensions. The difference part you people have already written in the last class. From here, start noting it now. See class, now regarding elastic collision in one dimensions. Yes, Harsha and Abdullah, you have joined quite late today. Okay, so in elastic collision, one thing we have studied was that momentum is conserved. Yes. So see, how do we write the formula of momentum? Okay, Wi-Fi was struck. Momentum's formula is mass into velocity. So what is this? M1 is the mass, U1 is velocity. So M1, U1. That is the momentum. M2, U2. Momentum's formula is mass into velocity. Fine. This becomes M1, V1. This becomes M2, V2. Now, if momentum is conserved, means all the initial momentum is equal to all the final momentum. Initial momentum means M1, U1 plus M2, U2. Final momentum is M1, V1 plus M2, V2. Total initial momentum is this, final initial momentum is this. Let's bring all the first terms together, means all the terms for the first body together, like M1, V1 and M1, U1 together. So that becomes M1, U1 minus M1, V1 is equal to M2, M2, V2. M2, V2. M2, V2 minus M2, U2. Fine. Now, what all things you can take common? From here, you can take M1 common, U1 minus V1. From here, you can take M2 common, V2 minus U2. Now, one more thing we have studied in elastic collision, that is kinetic energy is also conserved. So here, kinetic energy is also conserved. So initial kinetic energy is equal to final kinetic energy. Fine. Initial kinetic energy is equal to final kinetic energy. Now half m1 u1 square. What is the formula of kinetic energy? Half mv square. So mass is m1, velocity is u1. So half m1 u1 square. Now mass is m2, initial velocity is u2. So this becomes half m2 u2 square. This is the total initial kinetic energy that we have. Now coming to total final kinetic energy that we have. Mass is m1, velocity is v1. So this becomes half m1 v1 square plus this becomes half m2 v2 square. Now see, half gets cancelled. What are we left with? m1 u1 square plus m2 u2 square, m1 v1 square plus m2 v2 square, right? Now again, let's do the same thing. Let's bring all the one terms together. So m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. Again, let's take the things that are common. Masses are common. Let's take masses as common. So if we take m1 common, we obtain u1 square minus v1 square. m2, this is v2 square minus u2 square. So this is our second equation. First equation we have already conserved over here. This is our first equation. We have already preserved this. So let's take the ratio of second and 1. What is the second equation? This is m1 u1 square minus v1 square. On the right hand side, we have m2 v2 square minus u2 square. Divided by, there we obtained m1 u1 minus v1 and we obtained m2 v2 minus u2. So masses get cancelled. Now class, a square minus b square, that is, remember this identity. A square minus b square is equal to a plus b into A minus B. So we can put the same identity for this. U1 square is A square. So that becomes U1 plus V1 into U1 minus V1 divided by U1 minus V1. This is equal to V2 minus U2 into V2 plus U2 divided by V2 minus U2. So this bracket will get cancelled, this and this will be cancelled. What are we left with now? We are left with V1 plus U1 is equal to V2 plus U2. Let's rearrange the terms. U1 minus U2 is the relative velocity of approach and V2 minus V1 is relative velocity of separation. Yes. So what is the coefficient of restitution? See, E is equal to V2 minus V1 divided by U1 minus U2. Since both of them are same, we get the value of E as 1. So this proves, you will get to prove that coefficient of restitution is 1. Fine. So you have to show all these steps. You have to show that E is coming 1 in this particular case. Now you have values of velocity. These are the two formulas of velocity which you have to remember. It's just that you substitute the value of E in any of the formulas, you will get it. But no need to come to this step. This you will be able to remember the formula. The formula, see, just I will suggest now how I remember the formula is that I remember one formula, and in the second formula, wherever 1 has been written, I write 2, and where 2 was written, I write 1. See, V1 is equal to U1 into M1 minus M2 by M1 plus M2 plus 2 M2 U2 by M1 plus M2. Now, when I have to write for V2, I'll remember this. Now, when I have to learn for V2, what you do, wherever you have written 1, just write 2. 2, 1, so 2. 2, 1. 2, so 1. 2, so 1. And this is the same. This is the common denominator, that is M1 plus M2. So, or instead of writing this separately, this looks very lengthy. 2 M2 U2 plus 2 M2 U2 M1 plus M2. Remember it like this. These are the final velocities formula, which you have to put in the formula and calculate it. So let's practice some questions, but regarding their formula remembrance, these you have to remember. And how can you remember? Remember one at least. Second one, you will be able to do it by yourself. Write down this derivation of elastic collision in 1 dimension. See, Harsha here, E2, V2 minus V1 divided by U1 minus U2 is coming equal, no? Because of our calculations. So they'll get cancelled. That's why we are getting 1. Got it?
Okay.
It is saying predict the outcome of collision assuming it to be elastic. So 2 kg mass is there. This is colliding with a body moving with velocity 5 meter per second. The body with which it is colliding is 4 kg with velocity 2 meter per second. Okay, so yes, one direction that has been assumed positive, that rightwards we are taking it as positive. See class, this time both the bodies are not moving in the same direction. They are moving in opposite direction. And we have seen that velocity is a vector quantity. So we have to consider one velocity as positive, other velocity as negative. Fine. One velocity which moves in one direction as positive. So we have assumed in our question that let's take right as positive. So left will obviously automatically become negative. So what all things we have? 2 kg is M1, 4 kg is M2. Initial velocity is 5 meter per second. Initial velocity is 2 meter per second. For predicting the outcome, we have to have the values of what is V1 and what is the value of V2. So formula, firstly, let us find out this V1. What was the formula? U2 M1 minus M2 plus 2 M2 U2 divided by M1 plus M2. So substitute in the value U2 is, okay, let's put in the sign convention also. If leftwards is negative, so 2 will be negative, minus 2. So this becomes minus 2. No, U2, this U2 is how much? Okay, 5. We have taken M1 as 2 kg, no? So U1 is this. Wait. This we have taken M1 as 2 kg. So U1 is 5 meter per second. This is 4 kg and okay, fine, correct. So U2 is minus, how much was it? Minus 2. M1 minus M2. 2 minus 4 plus 2 M2 is 4. U2 is again minus 2 divided by M1 plus M2 is 2 plus 4. So this becomes how much? 2 minus 4 is minus 2. Minus 2 into minus 2 is 4. 4 into 4 is 16. This is minus 16 divided by 6. So this becomes minus 12 by 6, which is minus 2 meter per second. Fine. Now, what is this minus sign depicting? That is, it is towards the left hand side, because positive we have assumed to be the right hand side. Correct? Now coming to velocity v2. So in the second part for v2, it would be u2 m2 minus m1 plus 2 m1 u1 m1 plus m2. What is u2? u2 is minus 2. Okay, here it was u1. Yes, here it was u. I have written here u2, no? So this would be u1. If this is u1, this will be 5. See, this is u1. So this is 5. So 5 into minus 2, this becomes minus 10 minus 16 by 6. That is minus 26 divided by 6. We can use 2 also, minus 13 by 2, this much meter per second. So this becomes u2, yes. This is u2, m2 minus m1 plus. Now we'll take minus 2. What is m2? 4. So 4 minus 2 plus 2 into 2, u1 is 5. And what is m1 plus m2? 4 plus 2. So this becomes minus 2 into minus 2. This is minus 2. Then this becomes 4 minus 4 plus 20 divided by 6. That is 20 minus 4 by 6, which is this is 16 by 6. So this becomes 8 by 3 meter per second. Positive? It would be positive. So now we have the values of V1 and V2 with us. So when it says no, predict the outcome of the cases, this means you have to find out the final velocity. So what conclusion will you write? You have to mention something. What is your conclusion? So you will mention that you will write final velocity of, what was the mass for the first body? 2 kg. Final velocity of 2 kg body is 13 by 2 meter per second towards left. V2, final velocity of 5 kg, 4 kg, sorry. 4 kg body is 8 by 3 meter per second towards right. Fine, this is how you have to complete the answer if such type of questions. Note it down, then we'll see certain special cases which come separately in the exam from this part. Now coming to special cases, if your masses are same, m1 is equal to m2 is equal to m. So what you do, why are we studying these special cases? Because it will save your time. Why? See, v1 is equal to m1 minus m2 into u1 plus 2m2 u2 divided by m1 plus m2. If both of these are same, this will be cancelled. That becomes 2m2 u2 divided by 2m2. So 2m2, 2m2 will cancel. Why 2m2? Because m1 plus m2 can be written as 2m and m is equal to m2. Take this, write this as m. Instead of writing this as m1, m2, just write this as m. mm will be cancelled. So what is v1 equal to? V1 is equal to u2. And what is v2 equal to? v2 is equal to u1, means the velocities are interchanged. Now this is one very special case which you have to remember. Fine, m1 u1 were the initial ones, u2 and u1 and u2 were the initial ones, v2 and u1 were the final ones. But after moving, this has u2, this has u1. That's what it is saying. So if it comes as a theoretical part also, you should be able to mention. Then if the second mass is very huge, see, if this is very huge and this is coming and colliding, would this move? This won't move. Collision will occur. We will consider collision. Collision will occur, but this won't move. So we almost take this velocity as 0. So if u2 becomes 0, see, for v1 we have u1 m1 minus m2 plus 2m2 u2 divided by m1 plus m2. If u2 is 0, then this term becomes 0. So, and m1 minus m2 is approximately written as m2 only, the greater mass, right? If you are having a very huge thing and you're just subtracting very small from it, will there be any effect? No. 1000 minus 1 is all, not even 1000. 1000 is a very small number. Let's take 10 lakh. 10 lakh minus 1. You will write it approximately equal to 10 lakhs only. So this is something case like this. Or m1 plus m2 even if you take, that is almost equal to m2. So from here what we can do further replacements. That is v1 is equal to u1 m2 divided by m2. We are just writing this as it. So now what is the conclusion? v1 is equal to u1. This is the conclusion. Now the third case, if m1 is very much greater, so same thing will happen. v1 will be equal to u1 and v2 will be equal to twice of u because of the formula. Inelastic collision in 1D. See, in inelastic collision in 1 dimensions, no, what happens? Here you are having perfectly inelastic collision. The steps still here are the same. That's why I'm not repeating them. In perfectly inelastic collision, I have told you the bodies stick. So instead of having a v1 and v2 separately, we have a common velocity v. So that common velocity's formula becomes m1 u1 plus m2 u2 divided by m1 plus m. We had in the same derivation of elastic collision, we had v1 separately, v2 separately. But now since this is a common velocity, this is a common final velocity. And here loss of kinetic energy will be the same. Initial minus final. Why initial minus final? Because we know the value of u1 is greater than u2. That's why initial minus final. Fine. So in elastic collision, just remember this common velocity. Instead of v1 and v2, we are writing it as v1. And you just have to remember the formula of this velocity. That's it. Note down all these. Then one question is left. Then this lesson is over. In the next class, we'll start some portions of rotations are left because rotation, circular motion part we did, but moment of inertia and conservation of angular momentum. These two topics are very important which are left. Now, since we have already done circular motion separately, so not a lot of portion is left, but some important portions are left. So that we'll start on Tuesday. And one question is left that we'll complete today. Note it down first.
Can I please work once?
See, we have to find out the velocity in this 2 kg 5 meter per second, 3 kg 2 meter per second, and then we have a final velocity. So this final velocity we have to find out. And if it's perfectly inelastic, then how will we find out? See, velocity will be m1 u1 plus m2 u2 divided by m1 plus m2. V is equal to 2 into 5 plus 3 into 2 divided by 3 plus 2. So this becomes 16 by 5 meter per second. All right, note this as well. Yes, this is a part of one dimension. Two dimension is actually very small. This is two dimension is just similar to one dimension. That's why we are doing in one dimension in detail. This I'll tell you in the next class. A very small portion is left. Time is not here. It's just that we resolve the velocities in 2D. So the rest of the things remain the same. That I'll do in the next class only. It will just take 10 minutes. If you people have completed till here, then you can start leaving. All right, time is already 2 minutes are only left. You people can start leaving. Attempt your after class assessment. All right. So next class, next lesson. Thank you so much, class.
Thank you, ma'am.